Now that we explored the Redux basics, it's time to dive deeper. In this course section, we're going to dig a bit deeper into Redux, and we're going to explore some advanced concepts, specifically how we can handle asynchronous tasks with Redux, so sending HTTP requests and similar tasks. Then also where to put our code, and it will become clearer what I mean by that as we progress through the module. And we're going to take a look at the Redux dev tools, how we can use those, and why they're awesome. Now let's start with looking at asynchronous code and side effects in general, even if they should be synchronous, even if the code should be synchronous, and Redux. Because there is one super important rule. Your reducer functions must be pure, side effect free, and synchronous. So your reducer functions should take some input, in the case of the Redux reducer, the old state and the action, and then produce some output. And that's, by the way, not just the case for Redux reducer function. The reducer function you pass to use reducer, this React hook, works in the same way. It has nothing to do with Redux, but it's this general reducer concept that you have a pure side effect synchronous function that takes input and produces some output. And for the same input, for the same values, it will always produce the same output, without any side effects that happen along the way, without any asynchronous code that blocks it. No code of that kind must be part of your reducer functions. But of course, that brings up one important question. When working with Redux, when we dispatch some action that would involve a side effect, like a HTTP request that should be sent, where should we then put that side effect code? Where should we put our asynchronous code when working with Redux? Because the reducer function is clearly the wrong place, as we just learned. The answer to this question is that we have two possible places where we can put our side effects. We can put our side effect, possibly asynchronous code, directly into the component with useEffect, for example. So just as we did it before in this course. And then we only dispatch an action once that side effect is done. So Redux doesn't know anything about that side effect. Or, and that will be new, we write our own action creator functions. So we don't use the automatically generated ones Redux Toolkit gives us, but instead we write our own action creators. And it turns out that for those action creators, Redux actually has a solution that allows us to perform side effects and run asynchronous tasks as part of these action creators, without changing the reducer function, because that function must stay side effect free. Now we're going to have a look at both approaches in this course section, and to have a look at that, we are going to start by setting up another React Redux application. We are going to do that in the next 2 lectures, and you can therefore skip those 2 lectures if you don't want to repeat what you learned in the last course section, though I of course recommend that you don't. But we are going to repeat that, build a basic React Redux application in the next 2 lectures, and thereafter we're going to explore asynchronous code and Redux and all these shiny new things. Now, I got another starting project for you, to which we're now going to add Redux and some logic. And that will then be the project which we use in the next lecture to add some side effects and some asynchronous code. But before we do that, we need to add Redux. Because the starting project I give you has a couple of React components. And if you run npm install to install all dependencies, and thereafter npm start to start the development server, you will see this application here, this dummy application, which is not interactive. Clicking those buttons won't do anything. This is just dummy data. Now in this lecture, we are going to make sure that those buttons do something. And to be precise, I want to ensure that if we click the My Card button, we toggle this cart, so we show it, and if it is already showing up, we hide it. I want to make sure that if we click Add to Cart on a product, we do add it to the cart. And if it's already part of the cart, we just increase the quantity of the existing item. You can also add more dummy products for that so that you have more products to choose from. And in the cart, with these buttons, plus and minus, we also want to control the quantity. And if the quantity is 1 and we click minus, we remove the item entirely from the cart. Now that's the logic we're going to add in this lecture. And as I said in the last lecture, this also is a great practice for you. Try implementing all those features which I described, including that toggle mode for the cart with Redux. Potentially with multiple state slices if you want. Here is a pause for you to pause the video and try it on your own. Thereafter, we're going to implement it together, step by step, practicing what we learned. Were you successful? Let's implement this together. And for this, let's set up Redux in this application. Now for this, I'll first of all quit the dev server and then install @redux.js toolkit to install the Redux toolkit because I still want to use that. You could also use just Redux and just React Redux, but working with Redux toolkit simply makes working with Redux much easier. Now, one thing I forgot, of course, is that we still need to install React Redux though. So you should also install React Redux in addition to the toolkit. Now, once both is installed, we can start setting up our Redux logic and connecting it to the React app. For this, in the source folder, I'll add a store folder. Again, it doesn't have to be named store, but it is a common convention. And in that store folder, I want to add my index.js file, which will set up my Redux store and so on. And I also want to create multiple slices, one slice for managing the cart, and one slice for user interface logic, like toggling the cart, which should go into its own slice here. And therefore, I will create two files here, a UI slice.js file, and then also my cart-slice.js file. That's not a must-do. You could put it all into one code file, but splitting it up ensures that all the code stays maintainable and manageable, and we don't end up with super large code files. Now let's maybe get started with the UI slice, so that when we click my cart, we do toggle that cart area here. For this, in the UI slice.js file, I'll import something from @redux.js toolkit. And that something, as you learned, is the createSlice function, which does what the name implies. When we call it, it creates a slice. And you learned that it needs an object for configuration where we give this slice a unique name. And here I'll choose UI as a name, but of course the name is up to you. Then, in addition, we want to set up some initial state. And we can create a separate constant for this, or do it here on the fly, and I'll do the latter. And my initial state is that the cart is visible property is false, let's say. Of course, you can name this property however you want. That will be the property which controls whether the cart is visible or not, as you can probably guess by its name. Then we need the reducers key, which is a map of all the reducers. Or to be precise, it's a map of methods that represent all the different cases, the different actions we want to handle with that reducer. And here I actually only need one method, let's say the toggle method, which receives the old state and where I then want to set state cart is visible to the opposite of what it was. And we can write this mutating code here because you learned that when using Redux toolkit, we are not really mutating the state, even though it looks like we do. But instead, Redux toolkit will kind of capture this code and use another third-party library, Immer, to ensure that this is actually translated to some immutable code, which creates a new state object instead of manipulating the existing one. And that is our slice. Now I'll store it in a constant, UI slice, and then export this as a default here. And actually, that's not all I want to export. I also want to export the actions. So I'll create a new constant which I export, the UI actions, which we get by accessing uislice.actions. Now with that exported, in index.js, we want to create our store. And we do that by importing configure store from @redux.js toolkit. And then we call configure store here. And configure store then wants an object where we set up our root reducer. Now that can be a single reducer function or a map of reducers. And I'll go for the latter, even though at the moment we only have a single reducer because we only have one slice. But since we'll later have another slice, I'll set this to a map immediately and add a key of UI, though that is up to you. But I'll name it UI, and then add an import where I import the UI slice from /UI slice, and therefore as a value for UI, I point at UI slice reducer. So the reducer created by UI slice. Now that gives us our store here, and therefore we can export this store. Like this. With the store exported, we need to provide it to the application for it to have an effect. And we can do this in the index.js file, where we set up our root component, where we render our root application component. There we can import provider, the provider component from React Redux, and wrap that around app. So wrap provider around app, like this, and provide our store. Now for that, of course, we also need to import our store. So I'll import store from /store index. So from that index.js file, and set the store prop of provider equal to that imported store. That's how we provide our Redux store to the entire application. So to all components that make up our application. And with that provided, we can now utilize Redux inside of these different components. So for example, in the layout component, in the layout folder, in the main header component there, we got this card button. This card button, which when clicked, should show the card area. Now to make that work, we actually need to go to that card button component, which we find in the card folder. And then here we have our button. Now on that button, we now want to add an on-click listener to make sure that we can do something when it's clicked. And I'll add a new function in the card button component, the toggle card handler function, where I want to dispatch the logic for toggling the card. So for showing or hiding the card. And for this, of course, we need to dispatch an action which triggers this toggle method in our UI slice reducers map. So in this reducer functions map, to be precise. And we can do this with help of the UI actions which we are exporting. In card button, we can import UI actions as a named import because we export it as a named export. Import it from, and then going up a level and another level, diving into store, UI slice. From there, I import the actions, and in toggle card handler, we can then dispatch our action. For this, I'll bind toggle card handler to the click, and to dispatch, we need access to the dispatch function. Now we do get access to that by importing the useDispatch hook from React Redux, as you learned. We can execute this hook in our component function, and when we do so, this will give us access to the dispatch function provided by Redux. And we can now use this dispatch function here inside of toggle card handler, and then simply dispatch the action which is created by the UI actions toggle action creator. We need to execute toggle as a method here because, as you learned in the last course section, these auto-generated actions which you get here are actually action creator methods which you have to execute, and when you execute them, they return action objects. So it's then this returned action object which we dispatch here. And with that, we should trigger toggle cart handler whenever we click on the button. Now at the moment, of course, if we have a look at UI slice, we are then changing cart is visible, but we're not taking advantage of that right now. That's something we need to do, and for this we should go to the app component because that is where we render the cart. And I now want to render it conditionally based on that UI slice state value. So for that, inside of app component, we need to extract data from Redux. And we do that with another hook, which we import from React Redux. It's the use selector hook, as you learned. We can import use selector and then execute that in our app component function, use selector like this, not use effect. We execute this, and then you learned that to use selector, we need to pass a function which receives the Redux state automatically, because this function which we pass to use selector will be executed by React Redux. So it receives the current state automatically, and we should return the data which we want to use in this component. And in this case, that is this cart is visible property value. For this, we'll need to drill into that state slice, and since I'm setting up a map of reducers here in the index.js file in the store folder, we need to use this key to drill into that part of the state, so to say, and then use that property name in which we're interested. So here we need to access state.ui.cart_is_visible. That's how we extract that value, and then we can store this in a constant. Show cart could be the constant name. We can now use this to conditionally show or hide this cart component like this. If we do that and save this and restart the dev server to make sure that that's up and running, we should be able, that once it is running again, that we actually click my cart to show it and hide it. So that is working, and that's the first part. Now the missing part, and arguably the more difficult part, is that we now also want to manage the content of the cart. So the cart items should be updated correctly when we click add to cart or when we click plus or minus here. And actually the badge value here in the my cart button should also be updated. So let's work on this now. For this, I'll dive into the cart slice.js file and again import create slice from Redux at Redux toolkit. Then we create a slice here and configure it with an object. It gets a name, for example, cart. It gets an initial state, and it will get some reducers. And I'll come back to the initial state in a second. Now, what is our initial state here? How should the state of this state slice look like? Which structure should this state slice have? I think it makes sense to have some items, some cart items. And that should probably be an array of items. We probably also want to have a total quantity of items in the cart. And with that, I don't mean the length of this array, but the quantity of the items of that array summed up. And initially that's 0. And the total amount is probably also something which makes sense. So the total price, which also should be 0 initially. Though for this application, we actually don't need this because we're not showing the total price anywhere, so I guess we can omit this. But you could, of course, also add it. Now we also need functions in our reducer, so different actions which this part of our state should handle in the end. And here we clearly need a add item to cart action and a remove item from cart action, I would argue. And it probably makes sense to start with adding items. So here we get a state, and we'll also accept this action argument because this action, when it is dispatched, should carry extra information. We need to know which item should be added after all. So let's dive into this add item to cart function now. What should happen in there? Well, in there we should probably extract the item from the action, and there keep in mind that it will be the payload property which Redux Toolkit sets for you, which contains any extra data you added to the action. And here I assume that this extra data is another object describing the item that should be added. Now we could just push it to this array, but actually I want to check if it's part of that array already, and if it is, I want to increase the quantity of the existing cart item instead of push it as an additional item. So therefore, I want to get my existing item, let's say, by reaching out to the state items and finding an item in there where the item ID, let's assume that our items have IDs, is equal to the item ID of the item we're getting here. And since I now have a name clash, I'll name this here new item and refer to that here. So that's how I check if that item already exists. Now, if it does not exist, if existing item is falsy, so if it's not part of the array yet, then we want to add it. So then we want to go to our state items and push a new item. And that would be absolutely bad if you're using just Redux, because push manipulates the existing array in the existing state. And that's a must not do. But with Redux Toolkit, as emphasized before, we don't have that problem because their Redux Toolkit internally ensures that this will not manipulate the existing state, but that it instead transforms this into an operation which updates the state in an immutable way. So we can use push here when working with Redux Toolkit. And then we push a new object, let's say, to our array, where we have an item ID field, which is newitem.id, where we have a price field, which let's say is newitem.price, expecting a price field on all our products. Then the quantity, let's say, which is 1, hard-coded, because if we add our item for the first time, the quantity will be 1. And therefore we also have a total price, which is also newitem.price. It's price times quantity, but since quantity is 1, it's just the price. That could be an item which we push onto this array. Maybe we should also add the title, or the name, however you want to name it, of the product, and I expect this on newitem.title. Now these field names are all up to you because it will be your data which you manage. You just need to ensure that you then reference and create objects that have the correct structure. So with that, we're pushing a new item onto our products array. But we also need to work on the else case, so the item does exist. If that's the case, we want to update the existing item. Again, not something you should do with just Redux, but absolutely fine when working with Redux Toolkit. Then we reach out to the existing item and we update those fields on the existing item. The item ID does not need to be updated, the price also hasn't changed, but the quantity should be set to existing item quantity plus 1, and therefore we can of course also write it like this. The total price should be set equal to total price plus new item dot price. So we add the price, and of course that should be existing item dot total price. So we increase the existing total price by adding the item price again, and the name also hasn't changed. So we updated quantity and total price, and we're done. That's our add item to cart function here. Now when we remove items from the cart, we want to get a state in action, because again we'll get some extra payload that helps us identify the item that should be removed. And here I expect that my payload is just the ID of the item. I can expect this because I'm the one writing this code here. And with that, we now want to find that item and remove it from the array. Now we don't need to check if it's part of the array. We know that it will be part, but we need to find out how many items are in the array. So for this, again, I'll get my existing item by reaching out to state.items and finding the item where the item ID is equal to the ID I'm getting as a payload. And then we want to check if existing item.quantity is 1. If it's 1, then we want to remove the item from the array entirely. If it's greater than 1, we just want to reduce the quantity by 1. So the else case is simpler. In the else case that we have more than one item, we just reach out to the quantity and decrease it by 1. But if the quantity is 1, we want to remove the item from the array. And we can do this by setting state items equal to state items.filter, and then filter out that one item that we want to remove. That overrides the array of items with a new array where this item which we want to remove will be missing. And it will be missing because we filter for the item where the item ID is not equal to ID. So we keep all the items where the IDs do not match the one ID we're trying to remove. And therefore for the item where the ID is equal, we'll filter that out and remove it therefore. That's how we can update these items to remove the one item that should be removed from the array whilst keeping all the other items. And that logic should work. I guess we're going to see it once we test it, but it does look good to me. Now here's a quick note from Max from the future. I forgot one important step here, which you should add and which I will add later in this module, but which is missing at the moment. When we remove an item from the cart and the item is still part of the cart, so the quantity wasn't 1, then just updating the quantity as I'm doing it here is not enough. We also should update the total price of that item. And we do so by adding existing item.total price, total price, and setting that equal to existing item.total price minus existing item.price. So deducting the price of a single unit from the total price, since we are removing one unit. That's a line of code you should add here. I have not added it here. Again, I will add it later in this module because I overlooked it here. I'm just showing it to you right now because of course you should have that extra line in there. Now I'll store this slice in another constant, the cart slice, and of course we'll export it here. We'll export it as a file default, and we will also export the actions because of course we will need to dispatch those actions. So I export a named export here, I add a named export, exporting a constant, which I'll name cart actions, where I access cart slice.actions. Now in index.js, I want to merge this new slice into my overall Redux store. So I'll import cart slice from /cart slice and add this as another reducer in my reducer map. Maybe we use cart as a key here, and then here point at cart slice.reducer. Okay, with that we added this as well. Now let's wire it up. And for wiring it up, I actually need real products. In products.js, I have a hard-coded product here, and that makes no sense. This should be generated dynamically so that we have real product data with which we can work. Now we could manage our products with Redux as well. That might be a nice practice, setting up another slice for products. But since we don't do anything with the products, since we don't add or delete products, I'll instead just add a dummy products array here in the products component, which is an array, and I'll set up my dummy product data there. Now every product should have an ID, because in the cart slice, we are working with that ID here, and we should therefore also have a price and a title then. And hence here I'll add an ID, let's say an ID of P1, and a price of 6, and a title of my first book. And then also a description, because we need that down there for outputting the product item. So I'll add a description of the first book I ever wrote. It's just some dummy data, so I'm not spending too much time on preparing the best possible data here. Now I will add another product with an ID P2 and a price of 5, which is my second book. I'm super inspired, as you can tell. So that's the second book I ever wrote, and now we got some dummy data. Now I want to use that dummy data to dynamically render these product items. So here in the unordered list, I'll map all those dummy products into product items. So I'll paste that in there and set title equal to product.title, set the price equal to product.price, and you guessed it, set the description equal to product description. And since we're mapping, give every product item a key of product.id to help React. So now we got the product data. We can now work with that data. And I want to start inside of the product item. There I have the Add to Cart button. And we want to wire this button up to this function, to the Add Item to Cart function in our cart slice. So in product item, I will add a new function here, Add to Cart Handler, where I want to dispatch the appropriate action. Now, of course, we still dispatch actions as we learned it, so we import use dispatch from React Redux to get access to this dispatch function by then executing use dispatch in the product item. And then here in add to cart handler, I call dispatch, and now we need to get access to the cart actions. So I will import cart actions from going up, store cart slice, and then here dispatch cart actions dot add item to cart. Now we again execute this action creator function, but now we also need to pass data to it, because we now want to pass that product, which should be added, to that add item to cart function. We are expecting it there. Now there we need to work with the ID and price, and we need the title, so we should make sure that we send all that data. Now in product item I do have the title and the price, but not the ID. So I will also expect the ID as a prop now, and in products.js I will forward the ID, like this, so that we have it available inside of product item, and therefore inside of product item, when we add an item to the cart here, I pass an object as a payload to this action, and this object has an ID field which points at this ID which we're extracting from props, and we can therefore also use the shortcut and do the same for title and for price, so that this is the object we are dispatching. And again, I'm using that modern JavaScript shortcut here, where when the key name and the variable name holding the value are equal, we can omit the right side of that property assignment and just write down those property names, and it's automatically expanded behind the scenes. So we can just write it like this. This will now dispatch all the data we need to dispatch, and therefore we can now connect add to cart handler to our button. So here we add on click, and then point at the add to cart handler. If we do this, and I reload, that should work, but we can't tell because we're not really updating the cart, and we're not updating the badge here either. So let's maybe start with the badge. And for this, let's again go to the cart button component. There we already dispatch, now we also need data from the cart. We need the total quantity. And speaking of that, I just remembered that I forgot to update the total quantity. When we add an item to the cart, we don't just want to update the existing item, or the items array to be precise, we also want to update the total quantity field. And therefore, we can simply say that no matter if we have an existing item or not, the total quantity will simply increase by 1. We have one more item in the cart. That is safe. And the same is true for remove item from cart. No matter if we have that item in the cart once or multiple times, we definitely want to reduce the total quantity by 1. So we should add this code to remove item from cart. And with that, back in the card button, we can now read data from the state by also importing useSelector and then selecting a piece of data. So we call useSelector, pass this function for selecting data from the state, and dive into state.card, .card because in index.js here, we gave this a card key, and then into the properties we set up in the state of our card slice. So in this case, we're interested in the total quantity. Hence here we dive into state.card.total quantity and store this in a, let's say, card quantity constant. And now it's that card quantity constant which will output down there. With all that done, if we now save this, if I reload, if I add items to the cart, that badge on the top right corner updates. Now let's make sure we render this card correctly, and for that we need to go to the card.js file. There I have this list of card items, and at the moment it's hard-coded. So again here we want to use Redux instead and tap into our Redux managed card state. So since we need data from Redux, we need to import useSelector and import that from React Redux. And then here call useSelector and access state.card. And then there dive into our items because we want those card items like this. And then we can output them here. We can map our card items into card item components. And here, that card item expects an item prop, which holds an object of this shape. And the good thing is that in card slice, we already are setting up card items with a certain structure where we do have a price and a quantity and a total price and so on. And therefore we now just need to translate those properties which we have in our Redux store, in our Redux state, to the properties expected here. So we create an item on the fly, which we pass as an item to card item, and the title should be item.title here. The quantity should be item.quantity. Since in the Redux state, I am using quantity as a key as well. But I'm not using title as I just see, I'm using name. So in card.js here, we should reference item.name, since item is the data coming from Redux. Now the total price will be item dot, let's have a look, total price. So we want to access item.total price, and the single item price is item.price. So that's now the item which we pass into card item for every item we're getting from Redux here. Let's see if that works. If we save this, yeah, I can reload. Let's see. I got multiple items here, so that doesn't seem to work. It doesn't seem to get that we have an existing item. And I think I know why. If we have a look at card slice, I'm getting an existing item by comparing the ID of the stored item to the new item ID. The problem with that is that I'm storing the item ID in an item ID field here. So we should just change this to just ID here, so that when we extract the ID, we are successful. And if we do that and reload, if I now add the same item multiple times, it is grouped together. So now this is working, and we have to add a second item to have a second entry. And then that is also grouped together if we add more and more items. So that's working. We also should go to card.js and make sure that when we create multiple card items here, we do add that key again and point at item ID as a unique identifier. That has nothing to do with Redux, but helps React, as you learned earlier in the course. So now we got that. Let's now make sure the minus and plus buttons in our card items work. And for this, we need to dive into the card item and dispatch actions when they are clicked. So you know how that works. We import useDispatch from React Redux, and we need our card actions. So I'll import card actions from going up, store cart slice. And then here in cart item, we call use dispatch to get access to that dispatch function. And we then add new functions which will be wired up to these buttons. Let's say the remove item handler and then also the add item handler. Now, let's start with the remove item handler and let's dispatch that remove action. For this, we need cart actions dot remove item from cart. And that action wants a payload. It wants the ID as a payload. So we should make sure that this is passed on. And for this, we need to accept the ID as a prop in cart item. And in cart.js, again, make sure that we pass it as a prop. So actually here in this item object, which we're creating, I'll add the ID field and use item.id. And now inside of cart item, we get this ID here, and we can now pass this as a payload to the remove item from cart action. Now for adding an item, we want to dispatch cart actions add item to cart and execute that. And here we again need to pass in that object which add item to cart expects, this object, which should have an ID and a price and a title field. So back in cart item, this object will get an ID field with this ID. It will get a title field with that title and also the price field with that price. Like this. Now we just need to wire up these functions to our buttons. So on the first button, the minus button, I'll connect the remove item handler to onClick. And on the second button, it's the add item handler. And with that, if we save this, if I now reload again, I can add items, toggle my cart, and add them multiple times, also add them with this plus button, and also remove them with the minus. And if only one item is left and I click minus, it's removed entirely. So this is now working, and that's again Redux in action. It's nothing new, it's only what we learned thus far, but therefore it's of course a great practice. But now in the next lecture, let's add some async code and let's see how we can deal with that when working with Redux. So now that we repeated these core Redux basics again, let's dive into some brand new content. And let's see how we can connect Redux with side effects and asynchronous code. Now for this, I'll continue using this basic application on which we worked, but now I want to add a backend, a server to which we can send our cart. Because my idea is that whenever I edit the cart, because we add items or we reduce the quantity or remove items, whenever that happens, I want to send a request to a backend server to store that updated cart on the backend so that when we reload this front-end application, we can fetch that saved cart from the server, load it, and display it here. That is my goal. Now for that, as a backend, I will again use Firebase because it's that easy to use, no backend code required backend, which simply, well, makes our life as a developer a bit easier. Of course, if you are a Node.js developer, you could also build your own backend API and send requests to that, but that's simply not the focus of this course. Node.js is a totally different topic. I got a dedicated course on this. This course is about React instead, so we will focus on that. So therefore, I'm back on Firebase, using that Firebase project I created earlier in the course. And there I have that real-time database where some data is already being stored from an earlier course section. Now I'm going to get rid of all that data because we don't need it here. And instead now I'll use this backend here for my requests for this application. And now we got a couple of different kinds of requests that should be sent to that backend. As I said, whenever the cart changes, I want to update it on the backend. So whenever I add or remove items to or from the cart, I want to update that backend. And when I reload the application, I want to fetch my stored data from the backend. Because currently, if we add something to the cart, if we edit our cart, once I reload, all that data is lost because currently we're not storing that cart anywhere. And that's exactly the kind of problem I want to solve by storing it on that Firebase backend. But how do we now integrate that backend and the HTTP requests that we need to send to that backend into our React application that uses Redux? How do we do that? Now keep in mind, reducers must be pure, side effect free, and synchronous. So when we have any code that produces a side effect or is asynchronous, like sending a HTTP request, such code must not go into our reducer functions. So we can't send our HTTP request inside of the reducers in our cart slice after we edited our state here. We can't go to the end of the reducer and then use the fetch API and send a request to the backend. This would totally be against the idea of Redux. It would be super bad, and you must never do something like this. Don't perform a side effect inside of your reducer. No matter if it's synchronous or asynchronous, don't do it inside of the reducer. And never run any asynchronous code in the reducer in general. So we can't send the HTTP request here after we're done updating our state. Instead, when it comes to running such code, we have two main options where to put such code. We can execute it in the components, so we can simply ignore Redux if you want to call it like this, or we create something which is called an action creator, which we only used indirectly thus far, which also would allow us to run asynchronous code or generally any side effect code. These are our two main options. Now I want to show you both options so that you see the differences and can make your own choice which option you prefer. And let's start with running the async code, the side effect, inside of our components. Let's maybe start with adding items to a cart from inside the product item component. That means that in here we have this add to cart handler, and we could of course then not just dispatch an action to our Redux store, but we could also send that data to Firebase, to the backend. We would just have one problem with that. If we just send the product data to Firebase, so the data which we're sending to Redux here, if we just send that to Firebase, we would just store that product data in Firebase. But Firebase, the way we are using it, does not have any logic on its own on the backend. So on the Firebase backend, we don't run any extra code. So if we send some product data there, that product data would simply be added to the database, but all the logic we have in the reducer for checking whether a product is already part of the cart, and if it is, updating its quantity, if it's not, adding it, that kind of logic simply does not run on Firebase, because that's a pretty dumb backend here, the way we're using it, and therefore we don't have such logic there. Now, if you would be using Firebase for a real project, you could add server-side code to it. There is a service called Functions, which allows you to add your own code on the Firebase backend, which can be triggered for incoming requests and which would allow you to transform data on the backend. So it would be possible to integrate this here. And if you're using your own backend built with Node.js or PHP or whatever, if you build your own backend API, then of course you're also totally free to add code on that backend API that does more with the incoming data than just store it in the database. But since this is no course about backend API development and about backend programming languages, that's not the route I will take here. It's something you can do, but it requires knowledge about backend programming languages like Node.js or PHP. And we don't have that here in this course. Therefore, it's important to recognize that the code we need to write on the front end and where we write that code will depend on our backend code. Because we of course have our backend API, our backend server, talking to our frontend application with help of these HTTP requests and the responses which we send around. Now, if we would have a backend API that does a lot of work, so that does not just store incoming data but also transform it, if we had an API like this, then our frontend application could do less work. It could just send data, like the data for a product that should be added to a cart. It could send that data to the backend, let the backend do the transformation, and then use the response on the front end to then just there hand it off to the reducer, for example, to store that response. So then we could slim down our reducer and basically just take the incoming data, which is coming from the backend and which was transformed there. So let's say the final card, we could just take that and store that in Redux. That's something we could do then. But that's not the scenario we have here for the reasons mentioned a couple of seconds ago. Instead, here we have a backend that does not do a lot of work. It basically just stores incoming data in the format it receives it in. And that means that we do need to do more work on the front end. There, we don't just need to store data in the Redux store, we also need to prepare that data. We need to transform the data. So exactly what we're doing here in add item to cart and in remove item from cart. We are not just getting the finished cart as a payload on the action. Instead, we get a product and we need to find out how to add it to the cart here in this code. And the same for removing. And that's no problem. And it of course makes 100% sense if we have no backend. But if we do have a backend, it is at least something to be aware of, that depending on the backend and the amount of work the backend does, we could do less work here if the backend would do the work for us. But as mentioned multiple times, that's not the case here, and therefore we will need to find a way to still do the work here on the front end, and at the same time then send that transformed data to the backend without doing that sending inside of the reducer, because we learned that we're not allowed to do it there. So that's the problem set with which we have to work here. And therefore, let's now determine where to best put our code for sending the updated card to the backend if the backend is not doing that work for us, and we therefore have to do it here, and at the same time, we're not allowed to send our request inside of the reducer function. So I hope I could explain the problem set we're dealing with here in the last lecture. And it's not an uncommon problem set that you have a backend which might not be doing all the work you wanted to do it. And therefore we'll now have to find a way around that problem. As I mentioned, we can't send our HTTP request here in the reducer, but that of course then means that we need to find a different way. And here, these two main options where we can run our async code become important again. We can run it in the component or in an action creator. Now, as mentioned, let's start with the component. And here it's the product item where we have this add to cart handler where we send a request. Now, what we can do here is we can also use selector from React Redux and get our current cart before it's updated, then do all that transformation which we do in the reducer inside of product item without mutating the state though. That's important. We'll need to take care that we don't do that there. And then we send a request. And here's how that code could look like. I did not write this code together with you because this will not be the final code we'll use because it has problems. You'll find it attached though. You find this code snapshot attached so that you can also run it in your own project. What did I do? I worked on add to cart handler in the product item, and I first of all used selector from React Redux to select my cart from there, the entire cart. So this cart state object with items and total quantity. And then in add to cart handler, I create my own new total quantity. I don't change it in the existing state because we must not mutate the state here. And that's important. We can write this mutating code here inside of the reducer function in our slice because Redux Toolkit has this internal transformation for changing our code such that it doesn't mutate the state. But that only applies inside of those reducer methods. In product item, so in a regular component, that's not the case. And if here I would set cart total quantity equal to cart total quantity plus 1, then I would change a JavaScript object in memory, which is also part of the Redux store, without making Redux aware of it, because I would be changing it outside of a reducer function, which is horrible, which you must avoid. So that line, which I selected here, would be super bad code. You must never mutate Redux state, and especially don't do it outside of a reducer. That's why instead I create a new constant which has the updated quantity without changing the quantity in the Redux store yet. And then I do similar things for updating my items. I create an updated items constant where I copy the items in the cart with the slice method. That creates a brand new array with the existing objects, but a new array. Then I get hold of the existing item by identifying it in my copied items. That item, however, will still be an object in memory, which is part of the Redux store, because objects are reference values in JavaScript. So I copy that object into a new object as well. So that updated item is a brand new object in memory. And then I can update properties of that object without manipulating my Redux store. If I would be updating existing item, I would be manipulating my Redux store, not if I create a copy first though. And then I find the index of that existing item, and I replace the current item in my cart with the updated item. Or if we didn't have the item as part of the cart before, I push a brand new object to my updated items array. And then I derive my new cart by creating a new object where I set total quantity to that new total quantity up there, and where I set items equal to my updated items. And then I dispatch a new action because I added a new reducer in the store, the replace cart reducer. I added that off screen, and that simply gets the new total quantity and the new items from the payload and overwrites it in the Redux store. And therefore the payload which I dispatch is an object with a total quantity and an items key, and that's what I create here and what I then dispatch here. And I'm not sending a HTTP request yet, by the way. If I save that with the old action which we dispatched here, commented out, if I go back to my application and I reload, I can still add items to the cart as before, and it works as before. Now I did not change the logic that runs when I click the plus and minus buttons. Now what's the problem with this approach though? The problem is that if we would use this in all the parts of our application where we need to update the cart, so if we would also use it inside of cart item to be precise, then we would need to copy all that logic here, which I added to this component, to the cart item component as well. Or we outsource it into an extra file which exports a function which does this maybe. So then we don't have the code duplication. But still, we'll have another problem. We do the data transformation in some helper function and in the end directly in our components. We don't do the transformation in our reducers. We would be able to get rid of add item to cart if we used this replace cart approach in all the places in the application. And that means that our Redux reducers wouldn't do a lot of work. They just get some data and store it. That can be fine, and if that's your personal preference, that's not necessarily bad, but it's not the main idea behind using Redux. Because when it comes to the question where to put our code, we often have the choice between fat reducers, fat components, or fat actions. So when we consider where to put our logic, our code, then we have to differentiate between synchronous side effect free code and code with side effects, or code that is asynchronous. And that code which I provided to you in product item at the moment is side effect free. We're not sending that HTTP request yet, deliberately because I want to focus on this other problem we're currently talking about. All this code here just transforms data. It's asynchronous code and side effect free. Now, in such a case, if we're dealing with synchronous side effect free code, so if we basically just have some data transformation, so we're on the left side of the slide, then you typically should prefer reducers. Now, if you personally have a different opinion, if you like having your code in the component, that of course is fine. But generally, it is considered a bit better to prefer reducers and avoid action creators or components for that. Now, we still haven't had a closer look at action creators. We will soon, but we did definitely work a lot with components. And you want to avoid putting your data transformation code there when working with Redux. It would be different for asynchronous code or code with side effects. There, you should prefer action creators or components, and you absolutely must never use reducers. So therefore, at the moment, we have a problem. We have suboptimal code because we are performing the data transformation in the component and not inside of the reducer, if we rely on replace card. And that is suboptimal. That's the reason why we didn't write this code together, because I don't want to keep that code here. But what would be a better way of doing it then? Because we need to prepare it before we send it to Firebase, because we can't send a request from inside the reducer. Now, one possible better solution is actually totally obvious once you see it. Instead of using this approach, which I implemented in the last lecture, and which I'll therefore now get rid of, instead of doing that, and hence I can get rid of this card selector and of the use selector import, instead of doing that, we want to stick to the approach from before. We want to dispatch the add item to cart action and do all this heavy work inside of the reducer function. But if we now want to sync our new state to the server, so if we want to update the server with that new state which we derived on the front end, we can simply switch the order. We can first do the work on the front end and let Redux update its store, and then in a second step thereafter, we send a request to the server. But we don't necessarily need to do that here inside of the reducer function, where we wouldn't be allowed to do it. Instead, we can, for example, do it in the product item.js file or in a totally different file. Let's say in app.js as our root component. There, we can simply get hold of our overall card by basically using use selector and listening to changes to our card state. And whenever our card state does change, we can send a HTTP request. So that's what I'll do here. I'll use selector, which we're already importing, to get hold of my overall card. And then I'll store it in a constant like this. And now we can use effect, which we import from React, to watch for changes in our card state. Because you learned that use effect allows you to run side effects, so it sounds like a good choice here. And it allows you to run an effect whenever some dependency changes. So we import use effect from React, and we can then call use effect here in the app component, for example. And we could be doing this in any component. I'm just picking my root component here, but that's not a must do. So here we then define our effect function and our array of dependencies. Now inside of the effect function, I want to send a HTTP request with the fetch API, let's say, and I want to send it to Firebase. So we grab that URL from Firebase, add that here, and maybe target a card.json node. The .json is Firebase specific, This will create a new card node in the database and then store the data there. And we want to send a post request because that will tell Firebase to store new data. Or to be precise, actually here, I want to send a put request. That's also allowed by Firebase. And if we send a put request, we also do store data on Firebase. But the difference to post is that the new data will not be added in a list of data, so to say, but that it will override existing data. So when sending a put request, we'll override the existing card with the incoming data. And that's exactly what we want here. So we can send a put request and then set our request body to JSON stringify. And now here I want to send my card. So this card, which I get from Redux, I convert this to JSON data and send it as part of the request. Now, since we're using card in here, we should add it as a dependency to use effect so that this effect function re-executes whenever our card changes, which is exactly what we want. Now, the great thing is that useSelector sets up a subscription to Redux, so whenever our Redux store does change, this component function will be re-executed and we will get the latest state. So in this case, the latest card. So that means that effect will also be re-evaluated and it will re-execute if our card did change. And that is exactly what we need. So with this simple addition here, we will send this HTTP request whenever our card changes. And we can keep our logic for updating the card inside of the reducer because we simply switched the order. We first update our Redux store and we're done with that. And then we select the updated store to send a request. And that allows us to keep lean components, create a fat reducer with all the logic, and then perform any side effects that might depend on our Redux state. So if we save this and we go back here, if I reload, if I open up the network tab so that we can see HTTP requests, if I add something to my card, you see a HTTP request is sent. And that happens whenever I update my card. And if we go to Firebase, we therefore see the card there, and we see that here we have the correct card reflected. If I add my other item to the card, another request is sent, and the card was updated again. So that is very, very nice. And that's a very good way of having our side effect logic in a component and keeping all our data transformation logic inside of our reducer, which is where we typically want to have it when working with Redux. Now, at the moment, I'm sending this HTTP request and I'm not doing anything with the response, and I'm also not handling potential errors. That's, of course, something which we might want to avoid. Now, to handle the response and potential errors, I added a new component, which you find attached in a zip file, the notification component, which you should put into your UI folder. It's a simple component that displays a title and a message, and that can assume different CSS classes based on a status prop. And then it's simply a little bar at the top which will show up, which can either say something like sending request, or once it's done, it can tell us if it was a success or if we have an error. Now, to use it with our current approach in app.js, here on fetch, we can simply add then, or we use async await. Since we're in useEffect though, we should not add async here, but instead wrap this in a separate function then. And that's actually what I'll do here. So I'll add a new function here inside of useEffect, send card data. It's a simple function which will hold this code, but it's now asynchronous. So we can await this to get our response. And then when we get the response here, we can get our response data by awaiting response.json, like this. And we can also check if the response is maybe not okay. And if it's not okay, we have an error. So then we might want to throw a new error here, where we say sending card data failed or anything like this. If we make it past this line, however, we know that we were successful, and then we know that we, well, should show that success notification. And actually, we also want to show the notification right from the start when we start sending. Now for this, we could import use state and set up some local state in this component, some is loading state and maybe an error state. And we set those states as part of our HTTP request cycle here. And we then use those states to conditionally render the notification component with the appropriate content. We could do all of that. There would be nothing wrong with that, and it would be a good way of handling this. But since we already have a UI slice here in Redux, why not use that? Why don't we add more to the state we're managing here with Redux, and we manage the notification which we're showing with help of Redux now? For this, I'll add a notification property to the initial state, and I'll set it to null initially, so that initially we have no notification. But then we can add a new reducer, which we could call set notification or show notification maybe, where we get our state and where we also use the action, because I expect some action payload here, because the kind of notification that should be shown should be encoded in the action as a payload. And we then therefore set state notification equal to an object, let's say. Of course, the exact structure is up to you since it's your code. But I'll set it to an object where I have a status key, which I expect to get from my action payload. Let's say there we also expect a status property. And status could be something like pending, error, and success. And then we also expect a title, let's say, which we also get from the action payload. And a message, which we also expect as a property on the action payload. So we set our notification to such an object. Now we want to dispatch this show notification action when we start sending the data, when we're done with the data, and if we have an error. So therefore, we can import use dispatch from React Redux to get access to that dispatch function by executing use dispatch. And we import our UI actions from store UI slice. And then in here in use effect, when we send the card data, we initially dispatch UI actions dot show notification and pass an object to show notification where we set the status to pending, let's say, because we're currently sending the request, the title to sending maybe, and let's say the message to sending card data. That could be the notification we want to set now. Now I also want to dispatch an action once we're done, so once we got the response data. I actually don't care about the response data in this case, because for sending the card I'm not interested in any response, so we don't even need to get the response data. Instead, knowing that we don't have an error is enough. So then I want to dispatch a new notification where the status is success, and it should be success because I'm using that inside of the notification component then to adjust the CSS classes. So I'll set it to success, have a title of success maybe, and then we could say send card data successfully. Now if we have an error, I also want to dispatch, and I'll do that instead of throwing an error. I'll instead dispatch a new action where I say error, and then have error here as well. And here we could say sending card data failed, like this. Now this will not handle all kinds of errors though, because we could also have an error from some other part in this code instead of just having an invalid response status. And therefore I'll actually cut this and go back to throwing an error and simply go below this send card data function which we defined, execute it here, and then call catch here to catch any errors that might be thrown from inside this function. Since it's an async function, This send card data function returns a promise, so we can call catch on it. We catch any errors we might be getting here, and I then dispatch my show notification action with the error in here. And that then handles all kinds of errors that could occur. Now I'm getting some yellow squiggly lines here because card is no longer the only dependency here. The dispatch function is actually also a dependency now. The dispatch function created by useDispatch. We can safely add it to the dependencies array because React Redux will ensure that this is a function which will never change. So dispatch will never trigger this effect to rerun. Only card changes will. Nonetheless, for completeness sake, we should add it to get rid of these yellow squiggly lines. And now we are dispatching different notification states depending on the current status we have. With all those changes made, we can save this, and we now just need to use this new notification UI state. And I also want to use that in app.js. I already import useSelector, and now I just want to also select my notification status with useSelector from the state. So by drilling into state.ui.notification, I get that notification property. And that's either null initially, or it's an object as set by us, as dispatched by us. And therefore now we can use notification to conditionally render the notification component and to then provide extra data to the notification component. Now for rendering the notification component, I'll start by importing fragment from React because I want to render the notification component side by side to layout. And since adjacent JSX isn't allowed, I'll use fragment and wrap that around layout so that here we can then add notification. And of course, therefore import the notification component. Import notification from /components UI notification. And only render notification if we have a notification. So now I'll check if notification is truthy, and only if it is, I render notification. And then I set the status equal to notification.status. I set the title equal to notification.title. And I'll set the message equal to notification.message. With all that done, if we now save that code, I get an error, cannot read property UI of undefined. Yeah, because here I'm using useState. I auto-completed that incorrectly. That should be useSelector. We don't need useState here. So let's switch this to useSelector, save again. And now we have the notification right from the start when I reload. The reason for this is that it initially sends a cart request. If I reload and I have the network tab open, we see there's a cart request being sent to Firebase. So the good thing is we see the pending state briefly and then the success state, so that works. But of course, we don't want to send the cart state right at the beginning because that will then always override our existing cart on the backend with an empty cart when the app loads. Working around that is simple. In app.js, I just want to make sure that we don't send the cart when this runs for the first time. And for implementing this, we could add a variable here outside of our function. Maybe name it isInitial and set it to true. And I define it outside of my component function so that this does not change and it's not reinitialized if the component renders again. Instead, this will be initialized when this file is parsed for the first time. So when my application started, therefore, and that's exactly what I want. We can use isInitial here to check if isInitial. And if that's the case, I'll return. I'll not continue, so I'll not send my cart data. However, I don't just want to do that, but I now also want to set isInitial to false. So that this will never happen again, but it only blocks this cart data from being sent the first time this effect executes, so when the application started. With that addition made here, if I reload, we don't see the notification, we're not sending that cart request, But if I add something to my cart, we have the pending state and then the success state. And that works just fine. Now let's also test the error state by removing .json and therefore breaking that. If we now save this and reload, if I add to cart, we see the error state. So that is working exactly as it should, and therefore let's bring back .json. Now if we reload, we can send data to the cart again. So that is working, but of course we're never fetching that cart from Firebase, and therefore after a reload we still start with an empty cart again, because we're not using that Firebase data. And of course that's only one way of handling it, putting all that side effect logic into our component. And that's perfectly fine, but there is an alternative, and of course we also want to fetch data. Now before we start fetching data, let's have a look at the alternative of putting all that side effect logic into our component. That is perfectly fine, but we learned that it's only one of the two options. The other option would be the usage of an action creator. And that's something we haven't done up to this point. Or actually, we kind of did. We are using action creators all the time. Something like this here is an action creator. We get those action creators automatically by Redux Toolkit, and we call them to create the action objects which we dispatch. So these are these automatically created action creators. Now we can also write our own action creators, and we can write them to create so-called thunks. Now what is a thunk and why might we want to do that? A thunk is simply a function that delays an action until later, until something else finished. And we could write an action creator as a thunk to write an action creator which does not immediately return the action object, but which instead returns another function which eventually returns the action, so that we can run some other code before we then dispatch the actual action object that we did want to create. This might sound cryptic, but that's a very common pattern and it is easy to implement. So let me show you how it would work. And let's dive into these custom action creators, into these action creator thunks, by moving that code for sending cart data out of the component, though it would be fine there, but to show the alternative, let's move it out of there and let's move it into an action creator. Now for this, I'll go to cart slice because I want to write this custom action creator in that same file, because that is my file for managing the cart. Now to create our own action creator, we can go to the end of that file after this slice, that's important, so outside of this slice object, and there we can create a new function. Let's maybe name it send cart data. Now that is a regular function, and therefore of course as always you could create it with the function keyword as well. And here let's say we expect the cart data. Now we could write this as an action creator by now returning an action object in here. So an object with a type of whatever, and maybe some payload. We never did this ourselves because Redux Toolkit creates these action creators automatically for us for all those reducer methods. Every method in the reducer's object receives such an action creator, which is called by using that reducer function name. That's what's inside of these actions here. So we don't need to write such simple action creators on our own. But we could create an action creator which does not return such an action object here, but which instead returns another function. And of course, in JavaScript, you can write functions that return other functions. Now that would be a function that should receive the dispatch function as an argument, and we'll see where this is coming from in a second, and where inside of this function we can then therefore dispatch the actual action we want to perform. Like for example, showing a notification or adding a cart item. But before we call dispatch, we can of course do other things. Before we call dispatch, we can perform any asynchronous code, any side effects, because we will not yet have reached our reducer. we're not running this code in a reducer. It's a separate standalone JavaScript function instead. So in our case here, we could go to app.js and actually grab this dispatch action where we dispatch show notification, copy it, go to the card slice, and execute this in here. But for this, we need to get access to the UI actions, so I will import them. I'll import UI actions from UI slice, from that folder. If we do that, we can dispatch this action from in here. We can then also copy all that code here for sending the request and handling the response. And I'll not just copy it, I'll cut it. And I'll remove this dispatch code because we also copied that already. So now here we can execute this down here after dispatching that first notification. Now I'm using await here, and the great thing is we can convert this into an async function, this function which we return here. That is fine. Now here we need the card. Here I called it card data. Let me call it card here as well as a parameter so that we do get that card that should be sent. Now in app.js we can now also grab the other code like dispatching this action here, go to card slice and dispatch that if we make it past this if check. And now when it comes to handling the potential errors, I will actually create a new function, send request here, which is async, and put my code for sending the response and handling the response, for sending the request and handling the response inside of this function so that I can call send request here and await that as well because it's an async function. It returns a promise. And since we're still inside of this outer function where we also use async, we can use await here as well. And I know that's quite some nesting of functions, but this extra nesting here is required because of how the fetch API works. Because now we can wrap try catch around this await block here and catch any errors that might be thrown from anywhere inside of this function, and then dispatch our error notification as well. So here I'll first of all dispatch success inside of the try block if this succeeds, but if we make it into this catch block instead, I want to dispatch this error case instead. So we'll copy that into this catch block. So with that, what we're doing is we're creating a function, send card data, which immediately, without doing anything else, returns another function, an async function. We don't know yet who will execute that function, but we will soon know it. But in that function, we then dispatch a notification action. Then we create a new function, so yet another nested function, which we create on the fly, which is also async. In there, we send a request. This function is then called by us inside of try catch, simply to handle any errors. If we don't have an error, we dispatch the success notification. If we do have an error, we dispatch the error notification. So now we created this send card data function. How do we now call that function and where? We could of course call it from inside a component, but that's not the idea. Instead, in app.js, in there, I will clean up the content in useEffect. I'll keep useEffect though, but I'll clean up all the code in there. And I'll get rid of my UI actions import. I actually will keep that isInitial code though, where I return and set isInitial to false. I'll keep that. But other than that, I cleaned this up because now I want to do something which might look weird at first. I want to use send card data as an action creator. So in app.js, I still want to dispatch after this isInitial check, and I want to dispatch this send card data action, so to say. Therefore, I'll export it in card slice, and in app.js, I'll then import it. I'll import send card data, so that function which we just exported from store card slice from that file. And then here in useEffect, I dispatch send card data, and I'll execute it and pass my card as an argument. Now this might look weird. What we dispatched before always were action creators, so functions, that return an action object with a type and so on. Now in card slice, we are instead dispatching a function that returns another function. But the great thing about Redux when using Redux Toolkit is that it's prepared for that. It does not just accept action objects with a type property, instead it also does accept action creators that return functions. And if it sees that you're dispatching an action which is actually a function instead of an action object, it will execute that function for you. So Redux will execute that function for you. And with that function, I mean this function here. It will give us that dispatch argument automatically so that in that executed function, we can dispatch again. Because this is such a common pattern that we want to have action creators that can perform side effects and that can then dispatch other actions which eventually reach the reducers as part of a flow of side effects or as a flow of steps that should be taken. And that's what we have here. So we can use a function that returns another function as an action as well. That is built into Redux when using Redux Toolkit. So dispatching this here will work. And when we dispatch, Redux will go ahead and it will execute this function for us, and therefore all our other actions will be dispatched and the HTTP request will be sent. So if we save all of that, if we reload here, if I add something to my card, it works just as before. That still works, and Firebase is therefore still being hit, and all the data is still being stored in there. That still works, because that is a supported pattern by Redux. And why would we want to use that pattern? Well, it's simply an alternative to having that logic in your component. You can add that logic in your components. You can stick to the approach we had before. But it's also not a bad idea to keep your components lean, to not have too much logic in them. And at the moment, by moving that logic to this action creator function, we did achieve this. This component is now leaner. It only dispatches one action, not multiple actions. It doesn't care about sending the HTTP request, and all the hard work happens inside of our custom action creator function in our Redux files. And splitting our code like this could be considered good because it keeps our components lean. That does not mean that the other approach is bad. Both options are viable, and that's why I am showing both here. Now that we learned about funcs and func action creators, so these action creator functions here, now that we learned about that, let's build another action creator that fetches the card when the application loads. Because at the moment we're only sending data, but we never fetch data when the application loads. And therefore, if we reload, all our state is still lost. And that's of course not the goal. Now we can write that code in the component or as an action creator, but here I now want to stick to action creators. And hence we can add a second function in card slice. But since this file is now getting bigger and bigger, I'm a fan of creating a separate file for that. Let's maybe name it card actions.js. Of course the file name is up to you. I'll then copy this send card data function, cut it from card slice, and add it to card actions. And now we need to import UI actions here. So in card slice, I'll get rid of that import, cut that, and add that in card actions instead. And in app.js, we therefore now need to import send card data from store/card actions. And then I'll add my other action creator function in this card actions file as well. So that could be the fetch card data function. And I'll also export that because we'll need it somewhere else as well. And just as before, that will immediately return a function which gets dispatched as an argument and then does something else. Now here we could then also dispatch some notifications if we want to do that, but actually here I'll not do that. Instead, I'll create a new function, fetch data, another nested function, which is async, because I'll use the fetch API and I want to wrap fetch data with try catch thereafter. That's why I'm putting it into a separate function. So then we await fetch and get a response here. And I want to fetch by sending a request to that same URL again, but this time it should be a GET request. So we don't need to add this configuration object then as a second parameter, because a GET request is the default anyways. Instead, this time I'm now interested in the data. So in the result of calling await response JSON. But of course, I also still want to check if the response is maybe not okay for whatever reason. And if that should be the case, I'll throw a new error where I say could not fetch card data. Something like this. Now, if we make it past this line of code here, though, we have the data, and I'll then simply return it here. I'll return it here because that is in a separate nested function. Hence here, I'll then try executing fetch data and catch any errors we might be getting. And if we get an error, we still might want to show the error notification. So I'll then dispatch this error notification action again down here. But I'll say fetching card data failed. If we, however, are in the try block, I'll await fetch data. I can do this if I turn this into an async function, which we can. Redux supports that this function which we return here is async. So we can use await here as well. And that gives me my card data then, because I'm returning the data which we parse here. And therefore now I want to use that card data to set my card. Now the card data we're fetching will have that format which is stored on Firebase. And that's the format which we're sending to Firebase, of course. It will be this card which we're sending there. So it is an object with an items key, with an array inside, and a total quantity key, which is exactly the format we need here in our frontend as well. Which is no surprise because we are sending that Redux state snapshot as data to the backend in the end. So we automatically get back correctly formatted data here, and we don't need to transform that Firebase data first, because it has the format we sent to Firebase earlier. That's different from other sections in the course. There we had to transform Firebase data because there we used post for sending our data, not put as we're doing here, and hence we let Firebase create a list of data, which turned out to be an object when we fetched it. You might remember that from the HTTP section in the course. Here with put, we're sending our data snapshot to Firebase, and Firebase will take it as it is and store it like it is, without changing it. So when we then fetch it, we also have the correct structure, and hence this card data is correctly formatted, and therefore now we can use this replace card reducer, which I provided to you earlier in this module, to replace our frontend card with the card we're loading from Firebase. And replace card expects a payload which has a total quantity and an items field, which is exactly the data structure we're fetching from Firebase. So in card actions, we just want to import our card actions from the card slice, so these automatically generated actions now. And here I then want to dispatch card actions replace, not remove, replace card, and pass my card data as a payload, which, as mentioned, has the correct structure already. Now we could then also show the success notification, but I don't want to do that. I just want to use the card data and we're good to go. With all that done, we now just need to call fetch card data somewhere in our application to start fetching our card data from Firebase. And again, app.js is probably a good place for that. Here we already have a useFact call, and we want to start fetching data here if this application loads. We could do that here in this isInitial check, because that will only run if it's the first time that this effect runs, but I think it's cleaner to create a separate effect which simply doesn't have any dependencies, and which therefore also will only run if this component was rendered for the first time, and since it's our main component, this will only render once. And therefore here we can then dispatch this new card action we created, this custom card action. So this fetch card data action, I want to dispatch this here. Add dispatch as a dependency for completeness sake, but as I said, that will never change, so this effect will never rerun. And that will dispatch this whenever our application starts. Hence, if we save this and reload, you'll see that this gets populated. But you'll also notice that for some reason, we also see send card data successfully here. And we are sending a request to Firebase for storing the card data again. So we're fetching it. As we can tell, we have our card data here. And if I change it and reload, we see we fetch that changed data. But at the same time, we seem to be sending it again. And do you know why? We are sending it again because in app.js, we have this effect for sending the card data, which will execute whenever the card changed. The problem is when we fetch the card data, once fetching is done, we replace the card, right? We replace the card here with that fetched data. That changes the card inside of Redux. Now, since that card then changed, we trigger this other effect and send the card data again. So how can we now work around that? As always in programming, there will be multiple ways of fixing that issue we detected in the last lecture, where we automatically resend the card when the application loaded. One possible solution could be to go to our card slice, and here, in that initial state, we, for example, add a changed property, which is false, let's say, and we don't change this if we replace the card, but we do change it if we add or remove items to or from the card. Then we set state changed to true. And the remove item from card and add item to card are only executed from our local application. So when we fetch data from Firebase, where we then execute replace card, this will not change. It will stay false. Now, how can this help us? Well, in app.js, where we have this effect for sending card data, we can also check if card changed. So if our card, which we're selecting here, if that changed property is true, and only if it's true, we want to dispatch and send the card data. If it's false, so if it hasn't changed locally, we don't want to send it. And with this simple change implemented, if we reload, we're not sending this again. Only if I add something to the card. Now, as a side note, this changed property is now also part of Firebase because we're sending the overall card state as it's stored by Redux to Firebase. If we would want to avoid this, we could of course go to the card actions, and there where we send our card data, instead of taking the whole card, we could create a new object where we then just use items from card items and just the total quantity from card.total quantity. So we would create a new object which does not contain changed. That's something we could do, and with that, it is removed if we send something. Now it's no longer part of Firebase. So now that should be working as we want. Now we can add items to the card, change our card however we need to, add more and less, and that is then synced to Firebase. Though I see that the price here doesn't update correctly, we should look into this. But that's now synced to Firebase, and therefore this now works, at least when it comes to the side effects and to HTTP requests. We are, of course, also loading data correctly. I just detected that we have an issue regarding the price. It does not update correctly if I reduce my card quantity. So let's quickly look into that here in card slice, in remove item from cart. Yeah, for existing items, I'm reducing the quantity, but I'm not updating the price. we should of course be doing that. I'll set total price equal to existing item dot total price, not total quantity, thank you, total price minus existing item dot price to reduce the total price by the price of a single item, since we're removing a single item. If we do that, and I reload, and I clear my cart to start from scratch again, if we do that, and I try to start adding again, we get another error, and that actually is an expected error which I wanted to dive in. We're getting this error because I cleared my cart entirely, and I reloaded, and therefore I fetched my cart data from Firebase. Since I cleared the cart entirely though, we see that on Firebase here, we have no items key in the cart anymore. So we fetched that data from Firebase and we set our local cart to the fetched cart, and that means that items is now not an empty array, but undefined, and therefore trying to call find on undefined fails. To solve this, we should go to cart actions and to the place where we fetch our cart, and then when we replace our cart with cart data, there indeed is a tiny transformation we should make. We should make sure that the payload we pass to replace cart is an object which always has an items key, which is either cart data.items, or if that should be undefined and therefore falsy, an empty array. And total quantity is always cart data.total quantity, because that still is part of Firebase. With that, we ensure that we never end up with items being undefined. Instead, it will always be an empty array. With that, if we reload, we can add to the cart again. And now we can also deduct items from the cart. And now the price updates correctly. Can reload again. And this now all works. And now we also implemented HTTP and side effects with Redux. And you'll learn about different approaches of doing that. So now our cart is working correctly, and we learned a lot about where to put code, how to run async code with Redux, and how to handle side effects. And we spent a lot of time on that because it is an important topic, and knowing your options there is extremely important. I can't emphasize this enough. It's important to understand how that works. But besides handling async tasks and side effects with Redux and understanding where to put our code, there also was another important topic I wanted to have a look at in this module, and that would be the Redux DevTools. These are extra tools which we can use which make debugging Redux and our Redux state a bit easier. Because in more complex applications with a lot of Redux state handled by a lot of different slices and a lot of different actions going on, it can be difficult to find errors in your debug state, in the order of your actions, and so on. And sometimes it might be interesting to look into the current state of your overall Redux store without having to dive into different parts of the UI to verify that everything works correctly. And that is what we can use the Redux DevTools for. You can simply search for Redux DevTools, and you'll find a GitHub repository about the Redux DevTools. And the Redux DevTools can be used and installed as a browser extension. You can also install them as a standalone app, but I personally find the browser extension easiest to use. So here I'm on Chrome, so I'll pick that Chrome browser extension, and here you can install this Chrome extension. Now I already do have it installed. You can install it with a click of a button, and once you did so, you will be able to use it right away. When using Redux without Redux Toolkit, you had to set up some extra code to make Redux DevTools work. With Redux Toolkit, it will conveniently work out of the box, and you should then have access to that extension. Now here I have an incognito tab open, and there I don't have access to my extensions, so I'll quickly run the application in a standard Chrome tab again, and when I do so, I have this Redux DevTools icon here. Or in the browser DevTools, you also should find Redux here as an option. And if you open that, it will open this Redux DevTools panel here. And now here you have insights into your Redux store, into your actions, and much more. On the left side, you, for example, see the actions that were dispatched. And if I reload, we see that's init and replace cart. Init is this automatically dispatched first action that applies all your initial states to Redux, so that initializes the store. And replace cart was dispatched because we fetched the cart initially. Now, if I add something to the cart, you see add item to cart was dispatched and our show notification actions, which makes sense because these are all the actions which are being dispatched when we add an item. First add item to cart is dispatched, and when that cart state then changed, use effect in app.js kicks in and dispatches send cart data. That's not logged because that itself is not an action type, but instead as part of send cart data, we then do dispatch these notification actions, which is why we see them here as well. And you can click on those actions to get insights into the data that was transported by that action and how that changed your state. You see the data if you click on action. There you see the payload of the action and this unique identifier. Here we can also see the automatically created unique identifiers Redux Toolkit gives us. As you see, it's basically your slice name. So in cart, it's this slice name. And then the method name of this reducer method, that is the unique identifier created by Redux Toolkit. And then here we have our payload. We also see how the state looks like thereafter. So how the state looks after this action was performed. And we see how it was updated if we click on diff. There for add item to cart, we see that the total quantity was changed from 6 to 7. Changed was set from false to true. And in the items, we see that the quantity of that first item changed and so on. So that's super useful to understand the impact of your actions. You can even do something which is called time traveling. You can jump to an older state like this one by clicking on it and then clicking on jump. And you see, now the notification is gone and we're back to the cart with 6 items. And we can then start debugging here again if we want to. And we can then also jump back to a newer state if we want to. So that can be really convenient, and therefore the Redux DevTools are a piece of software I can only encourage you to use and play around with to get deeper insights into your Redux store and to debug your Redux behavior and fully understand what's going on. Now with that, that's it for this module. We again practiced using Redux, and more importantly, we learned about a very important concept. We learned about Redux and side effects and asynchronous code. We learned that there are different places where we can put this asynchronous code or where we can put such side effects, our components or action creators, and we saw both in action. We also saw how not to do it when we added all the data transformation code in the component, which led to a very fat component. And whilst that was working, it simply was not the idea behind using Redux. There you should prefer reducers for data transformations and only put side effects or async code into your components or action creators. So that's what we did thereafter. And we then also moved from component to action creator to learn about that concept as well, which allows us to keep our components lean and focused on a couple of core tasks instead of doing all the heavy lifting. Then at the end, we also had a look at the Redux DevTools, another important piece of software which allows us to fully understand our Redux store and state and what's going on, where we can time travel, and where we can gain deep insights into Redux. And therefore, now after this module, you learned a lot about Redux, a lot of advanced concepts, and you are ready to use Redux in any kind of application you might be building with any kind of logic you might have in this application, including side effects, HTTP requests, or any other kind of async code.